Hello and welcome to Engineering Ethics at NJIT. I'm your instructor Daniel Estrada, and this will be the lecture video for Lesson 1, Engineering Social Systems. In this video, I'll introduce the lesson themes, and I'll introduce some of the lesson readings. You can see all of the readings on Canvas if you go to canvas.njit.edu and scroll down to this Engineering Social Systems Lesson 1, Readings and Links. Right now this video is out of date. I will replace it with the current video shortly, but here are all the readings. These readings are also in the slideshow, and the slides have been updated for the fall 2019 semester. So let's jump into the material. For this first lesson, I want us to think very generally about the relationship between ethics and values on the one hand and engineering on the other. We tend to conceptualize these as very different, that engineering is really about math and science and not about values, and that values are a humanities topic or philosophy topic or sort of outside the scope of hard STEM research. And this is just not true. There are in fact lots of very deep connections between values and engineering, and this first lesson is just exploring and taking our first steps into these topics. So there's lots of approaches you might take to these questions, to this very general question about the relationship between values and engineering. One is you might think about your own values and how that has influenced your career path and your choice of an engineering major. But you might think more generally about social values and how those influence the kind of engineering projects that get selected and funded and actually built. How the engineering projects that develop are a reflection of and informed by the values both of their designers and engineers, but also of the larger, broader society. Again, these are very big philosophical questions, really just sort of get our appetite going for more detailed discussion in this direction. Also remember that your assignment for every lesson is to first take a short quiz on the required readings and then write a 500-word weekly essay on every one of these themes. In order to prepare for that essay, you want to go through the readings, but you also want to sort of think about things, maybe talk about them with friends, maybe cases or interesting issues you want to talk about with friends or family. Maybe you want to do some of your own independent research. I recommend letting these ideas stew for a bit, think about them, mull them over for a bit, see what you come up with. Also decide. Remember, there's way too many readings here that anyone can do them all in a single week. I'm not expecting everyone to master these readings, much less go through all of them. What I really want you to do is find something in this sort of mini mountain of literature that you're interested in and that you want to talk about and that you want to bring to the attention of the class for more conversation. I will just touch on these things in this video, but there's a lot of material here, there's a lot of things to say, and so hopefully you can find things that motivate you to write for 500 words. You can also check this slide in the actual slideshow on Canvas for the attendance password for your semester. Alright, so on this issue of the relationship between engineering and values, between engineering and ethics, there's lots of ways to approach. I have lots of readings that give you different options for how to approach this. The first here is from President Hoover, who, before becoming president, was also an engineer. In his memoirs, in his autobiography, which was several volumes long, he had a lot to talk about. But he also reflects not just on his presidency, but also on his career as an engineer and of the importance of engineering generally. So in this passage, and this is just a selection, you can see the longer quote at this link or in the main reading selections, so you can see this quote in context. But Hoover here is talking about the great liability of the engineer, and in particular the liability relative to other professions. So I'm going to just read the quote. "The great liability of the engineer compared to men of other professions is that his works are out in the open where all can see them. His acts, step by step, are in hard substance. He cannot bury his mistake in the grave like the doctors. He cannot argue them into thin air or blame the judges like the lawyers. He cannot, like the architects, cover his failures with trees and vines. He cannot, like the politicians, screen his shortcomings by blaming his opponents and hope that the people will forget. The engineer simply cannot deny what he did. If his works do not work, he is damned. So what is Hoover getting at here? Maybe I can let you think about this for just a second. Hopefully we talk about this in the discussion sections. What is Hoover getting at? So Hoover is talking about the liability or the sort of unique responsibilities of the engineer, and responsibilities that open the engineer up for certain kinds of risks, or maybe even social blame that other professions don't face. Right? So in some sense, Hoover is saying that these other professions, the lawyers, the doctors, the architects, that they can get away with shoddy work, that it's hard to hold them accountable for bad work, but that the engineer cannot deny that he did it. If his works do not work, I'm sorry about that. If his works do not work, he is damned. That the engineer can't hide his mistakes, and he, in some sense, has to face up to them. Hoover is obviously speaking from a different time. His language is very gendered here in a way that's not entirely appropriate for the profession of engineering, which is much more diverse than he's picturing. And maybe Hoover isn't entirely fair to these other professions. Would you agree that engineers have a greater responsibility than even doctors and lawyers and judges and architects? Is engineering really so unique? I mean, doctors have the Hippocratic Oath. They have malpractice insurance. It can be very expensive for doctors to maintain their malpractice insurance if they make mistakes. There are ethical codes that bind doctors and also lawyers and architects, maybe less so the politicians. But do engineers really have a greater liability, an increased responsibility? And if so, why? What is it about the engineers that distinguish them from these other professions? One issue that will come up over and over again is that engineers have specialized and technical knowledge that the general public doesn't always share. And because of that technical knowledge, engineers are in a unique position to, for instance, be able to spot safety concerns, to know that a bridge is going to collapse. Some people might see bridges and think that cracks in them might collapse, but maybe an engineer knows that those cracks are structural and they're supposed to be there and so on. Does the technical knowledge that an engineer have, does that give them certain greater ethical responsibility or liability? Engineers do have technical knowledge, but so do doctors and lawyers and architects, so maybe that's not it. Is there anything else that distinguishes the engineer from these other professions? I'd especially like to hear from people who are not engineers or planning on becoming engineers, what they think of Hoover's comments here. But I sort of like to start the engineering ethics class with this quote because it sort of reflects well on engineers. It makes them out to be a certain kind of hero. Here's another take on the relationship between values and ethics and engineering. This comes from our textbook, Martin and Schenzinger. Please make sure you get the Martin and Schenzinger book by lesson 2 when it will be required for the quiz. But this textbook has lots of good things in it that we'll use, but it's also sort of framed around an analogy between, on the one hand, engineering and on the other hand, scientific experiments. The authors note that that scientific experiments are often carried out in ignorance. You don't know how they're going to turn out, and that you gradually get better in your scientific experiments. You gain control or precision or whatever through improving on previous successes, right? So you try things out. Sometimes they fail, sometimes they succeed, and a good science sort of takes advantage of those successes and improves its results over time, sort of learning from the past. And Martin and Schenzinger argue that engineering is similar. You don't always know the results of engineering projects before they start. They can have uncertain outcomes, sometimes possibly disastrous outcomes. But that good engineering practice involves learning from those mistakes or successes and improving and building better, more reliable, more stable, more efficient, more socially beneficial engineering projects. So while there is this analogy, there's also some important disanalogies between engineering projects and scientific experiments. And in particular, this has to do with how engineering projects are conducted. In scientific experiments, experimenting on human subjects is an ethically problematic issue. And in order to conduct experiments on human subjects, there's all sorts of ethical requirements, advisory board oversights. There's usually a process called IRB, which is the Internal Review Board or the Ethical Review Board, that validates that the experiments on humans won't cause unnecessary harm, and in particular that the experimental subjects are giving their informed consent. So this is important for all sorts of experiments, psychological experiments, even medical experiments. A doctor is not allowed to try an experimental technique on a patient without that patient giving their informed consent. So consent here just means that the patient agrees to the procedure. But it's important that it's not just an agreement, not just that they said yes, but that yes is backed up by solid information, that the subject, the patient, fully understands what the procedure amounts to, what the risks involved would be, what those risks means for that patient's own ability to go through that procedure, and so on. It's only when the doctor has fully informed the patient that the patient can give their informed consent. Now, again, the doctor is going to have technical information that the patient might not be able to fully handle. The doctor doesn't need to give the patient a degree in medicine in order to give consent. But the doctor should give enough information that the subject can make an informed decision. Now, there's complications here, maybe a surgery on a child who's not old enough to give their informed consent. Other kinds of complications, maybe a patient who's incapacitated for whatever reason and cannot consent. So there's lots of complications here, but in general, experimenting on humans, testing things out on humans requires their consent in order to proceed. Otherwise, it's a big ethical violation and a scandal. Typically, you do not have consent in engineering projects. I mean, a bridge, for instance, might be funded by taxpayers. Maybe there was a vote at some point. But usually everyone who drives on that bridge is not giving their informed consent. Usually they're not informed about the engineering techniques and procedures used to build the bridge, the materials used, how safe the bridge is, when the last time it was repaired and monitored. Usually the public is sort of at the mercy of the engineers and the public infrastructure that decides which engineering projects are built, right? So giant bridges or large buildings or other kinds of engineering projects that affect the public safety and health and well-being. It's typically the case that the public is not giving their informed consent for those projects to go through. Maybe there's some democratic oversight, but it's usually not the kind of informed consent that is typically required for human experimentation. And what that means is that people, engineers, and large engineering projects end up doing things like experimenting on the public without their consent. Typically, you're not going to build an experimental bridge before you build the real bridge. Usually, you just build the real bridge. Maybe you experiment on parts, but you build the real bridge as a one-off deal. And this is not the kind of experimental control that scientific experiments usually have. So informed consent is just about making sure the patient understands and is giving their agreement, consent in a voluntary and fully informed way. Now, just on this topic of informed consent, you might be interested to know about some of the history of why this is now an ethical requirement for human experimentation. A lot of this has to do with this Tuskegee syphilis experiment, which was conducted from 1932 to 1972 in the United States. If you're not aware of this experiment, this might be a little bit shocking, but the U.S. Public Health Service, the federal government, conducted a large-scale, long-term experiment on human subjects about the effects of untreated syphilis. So syphilis is a sexually transmitted disease. It can kill you. And there are, and have been for a while, medications you can take, antibiotics, I think, that you can take to treat syphilis. But the government wanted to know what happens if you left syphilis untreated. So they decided to conduct this experiment in secret on 600 sharecroppers from the South. They were black sharecroppers who were poor, who might not have been fully educated on the disease or its consequences, and who were explicitly not informed about the experiment that was being conducted on them. So these were patients that were found that had syphilis, and the doctors, the public health service, decided that instead of treating the syphilis, they would just monitor the patient over the next few decades. That includes not just the patient, but all their sexual partners, maybe their wives or children. And wives and children died as a result of this experiment. And they conducted it for several years, all the way up into the 70s. And in the 70s, this ended partly because a whistleblower decided to inform the public that this experiment was going on. So a whistleblower here is someone with inside knowledge of some ethical wrongdoing who goes outside of the normal procedures for dealing with these ethical violations in order to end it more quickly. So in this case, someone went public with it. And once there was public scrutiny on this, the program was shut down. But the government deliberately experimented for decades on people. This isn't the only such case. Maybe this isn't the worst such case, but it's a very famous case that had an impact on how laws work. Just because the laws have changed doesn't mean that we always follow these laws. There have been several ethical violations associated with Facebook, including violations. Now in 2019, we're very familiar with a lot of these. But there was, in 2014, an experiment published from Facebook researchers, psychologists who were working with Facebook, about the impact of manipulating users' data streams. So what they wanted to know at Facebook is if you show people more negative posts, do they post more negative things? If you show more people more positive posts, do they post more positive things? Does the emotional valence of the user's stream impact the kind of activity that they exhibit? Unsurprisingly, we should all be pretty familiar with this. It does have an impact. You show people more negative things, and they'll post more negative things, and show more people more positive things, and they'll post more positive things. But the Facebook researchers wanted to know this with scientific methodology, and they have one of the largest social networks ever created, maybe the largest social network ever created, over 1 billion users. It's a very juicy data set to experiment with, and so Facebook sort of deliberately manipulated users' feeds in order to see the results here. They did this without consulting them, without the informed consent of those users. The researchers claimed that because the terms of service for the Facebook app, insists that Facebook is free to do this kind of experimentation, that this did not violate the privacy of users because the users had agreed to those terms of service. But the issue here isn't was it in the terms of service. The issue here is whether it was an ethical violation of informed consent. The terms of service usually are not a case of informed consent. People don't read the terms of service. They just scroll through and click agree. So calling terms of service an example of informed consent is questionable. Of course, Facebook has had many other sort of questionable ethical scandals in the last few years. I have recently updated this, if you click on this link, ethical analysis, of a few years after the Facebook study came out. Some ethicists go through the kinds of ethical challenges that result from not just Facebook, but social media generally, and the privacy and experimental ethical challenges that result. So if this is the kind of thing that interests you, maybe you want to write your posts on one of these things. This is just a little bit of background on informed consent and why it's so important, and why it's a big ethical deal that engineering projects usually don't require this kind of informed consent. So moving on, so this informed consent and sort of the analogy to science is another way of approaching the question about the relationship between engineering and values. Another way, and this is related to one of the major readings for this lesson, is this article, Do Artifacts Have Politics, by Langdon Winner. The question, do artifacts have politics, might seem curious to some of you. Usually we don't associate artifacts with politics. I think the general view is something that philosophers of technology sometimes call technological neutrality. People tend to think that technology itself is not political, that technology or artifacts don't have ethical values on their own, but that people have ethical values, and that technology and artifacts are tools used by people for whatever purposes they have. And so if technologies do bad things, it's because the people that use them did bad things. And if technology does good things, it's because the people that use them do good things. And the idea is that the good or the badness, the ethics, is really in the people who use these tools, but it's not in the tools itself. The tools themselves don't do anything on their own. So I think this is a very popular view. I think a lot of people share this view. Maybe this view is captured in the popular NRA slogan that guns don't kill people, people kill people. Or the idea that the guns aren't themselves good or bad. They can be used for good or bad purposes depending on what people do with them. So if people want to use them for bad things, if people want to use guns unethically, then people will use guns unethically, and if people don't, then they won't. But it's not the guns that are unethical, it's the people. So I don't want to get into a guns rights debate. I would caution people from getting too heavy into a guns rights debate. The issue here isn't whether guns are good or bad in themselves, but just about whether... the issue here isn't whether we should ban guns. I don't want to get into the legal stuff too much. The issue is just whether the artifact has a social value, has a valence, has an ethical valence. So if you disagree with the NRA here, that guns don't kill people kill people, there's a variety of ways you can do this. One other common and rather popular way is sometimes called technological determinism, or we might distinguish between hard and soft determinism. But the idea here is that technology isn't neutral, but that technology actually has an influence over how people behave. And that influence is not contingent on what people do with it. So that you might think, in some sense, that technology has a mind of its own, or that technology has a will of its own, or that technology develops in ways that don't merely follow the interests and desires and goals of people. That people might have some goals, but the technology might develop in ways that sort of radically undermine those goals or confound those goals in some way. Maybe a popular example of this is something like computers. When computers were first invented, the people who invented them thought that they might have some applications in business, maybe in government. Maybe we'd only need a few large computers to do any real serious computing work. But for thousands of years, humans have survived without computers. So the designers, the people who engineered computers, did not think that they would have wide value or application. But it turns out now computers are everywhere. And that's not exactly what the people who designed the computers, who invented the computers, intended. And the same thing goes for telephones. Telephones were designed with business and government applications in mind, and it turns out that people just like talking on them. And this is not something that the inventors of the telephone really anticipated. But because the technology ends up having this impact, it ends up changing the world. And so, we might talk about like the digital revolution, and that the digital revolution influences the course of history, the organization of society, and our political interests. And it does this not because we're making it happen, but because this is somehow the force of technology on its own. That technology has its own sort of force, like a force of nature, like a hurricane. Hurricanes don't happen because people make them happen. Hurricanes just happen. Maybe we make it happen in some extended sense because we're warming the planet, and the hotter the planet is, the more hurricanes there are. But we don't cause this or that particular hurricane, and we don't have a lot of control over this or that particular hurricane. It just sort of happens to us, and we have to deal with the consequences. The technological hard determinism thinks technology is the same sort of way. Technology happens to us. It's not something that we use like a tool. It's something that happens to us, and we have to deal with the consequences. And sometimes those consequences are very unpleasant. Sometimes technology does things to us that aren't good for us, that actually we should be very skeptical of or resistant to. Maybe cell phones, smartphones, everyone always on social media. Maybe this is bad for our psychological health. Maybe this is bad for our social and political health. But maybe we do it anyway, despite despite it not being in our interests. And maybe to some extent we can't help but just get sucked into our phones. Maybe the technology is designed so attractively that we can't help but sort of reorient our life around the technology, right? And this is the thesis of technological determinism. I'm not arguing that any of these is right or wrong. Maybe the NRA is wrong. But what I am arguing is that these are sort of different perspectives on technology, and a technological determinist might argue very seriously that artifacts do have politics. That in fact it's very politically important that we understand the impacts of technology independent of how people use them. I mean, you might think that maybe people can use guns for good or for bad, but the fact that we have so many guns in the United States, that there's like 5 guns for every person. We have more guns per capita than any other place in the world. Maybe we don't need that many guns, and maybe just the fact that we have so many guns creates a safety hazard. That's not just about how people use it, but it's just having this many guns around, you're going to get a lot of accidents. You're going to get accidents even among people who are very responsible gun owners and users, people who do not have malicious intentions. So maybe just having that gun around changes things. If hard determinism seems too deterministic for you, there's also versions, sometimes called soft determinism, where we do retain some control, and the question is, how do we maximize that control, or how do we have the best, the biggest impact how do we have the biggest impact on the effects of technological change? How do we best control and direct the course of technological change? A soft determinist view here sort of reminds me of what's called Kranzberg's first law of technology. That technology is neither good nor bad, nor is it neutral, which sort of seems to exhaust the options. So what's left? Well, one thing that's left is thinking about how artifacts develop within their political environments and what are the impacts of those things. So there's maybe some cases here where these are cases that are all gone through by in the Langdon-Winter article, Do Artifacts Have Politics? The one case I want to focus on is Robert Moses. Winter goes through many more cases than this, but the Robert Moses one is compelling, I think, and relevant to thinking about engineering and values in this very general way. Maybe some of you are familiar with Robert Moses, especially in the civil engineering and architecture students in class. But if you're not familiar, Robert Moses, sometimes called the master architect of New York City, a lot of the design and layout of the city, where the parks are, where the roads are, where the bridges are, was the result of Robert Moses' decisions. Now, one interesting thing is that Robert Moses was never elected to a public office. He just had a lot of power and influence in the city, political influence. And so basically what he said went for a lot of these engineering and public works projects for most of the 20th century, from the 1920s through the 1970s. So, for instance, in Manhattan, you know that there's highways along both sides of the island. All that riverfront property is taken up by a big overpass highway, which you can see a little bit of in that picture. That was Robert Moses' decision. You can thank him for that. He built a lot of the parks, and very famously, Robert Moses was racist. Not uncommon to his time period, but Robert Moses was especially racist, and he was very concerned that his public projects, and especially his public parks, were used by the right people. One way he ensured this, and this is especially the case for Jones Beach, which is a beach in Long Island that Moses designed. There's only a couple of roadways into Jones Beach, and Robert Moses designed those roadways with overpasses that were deliberately low, deliberately short, so that public transportation buses couldn't go under the overpass and would have to stay on public roads. Because they'd have to stay on the side roads, it couldn't go down the overpass to Jones Beach, which means you didn't get any public transportation to Jones Beach, which means the only people that could go to Jones Beach were people wealthy enough to own their own cars and have means of commuting back and forth. The people who had to rely on public transportation, which in particular are low-income groups and minority populations, like black people, black and brown people. New York is a very diverse population, and a lot of the lower income of that Robert Moses wanted to keep out of his beaches. So he designed the overpasses of his highways low to keep out these public buses. So that's bad, and maybe in 2019 we might agree in this class that Robert Moses was a bad dude, that making these kinds of decisions is not a very ethical thing, and that we should avoid being like Robert Moses. Now, of course, that's not the case in 2019 that everyone's like this. People are still very racist and make these kinds of decisions still today. But maybe in conversation and ethics class, we can all agree to some extent that Robert Moses' decisions here were wrong, that discriminating against racial minorities and low-income groups is wrong, that everyone should have access to public services and public parks, and that designing infrastructure that deliberately keeps certain people out is an unethical thing, that Robert Moses was a bad guy for doing this. It's a pretty wide consensus that Robert Moses was an unsavory character in this regard. But Robert Moses is dead, and maybe none of us share his opinions. Nevertheless, his overpasses are still there. The low overpasses didn't die with the man. These aren't these racial attitudes, these racist attitudes aren't just in Robert Moses' head, and they don't just die with him. He built them into public infrastructure, concrete and steel bridges, and those bridges are still there, and they still affect who can go to Jones Beach and who can't. If you've ever taken a bus to LaGuardia Airport, you know that the buses can't go on the highways, they have to go on the roads because the buses won't fit under the overpasses. Right, so these are things that still affect us today. Even if all of the racist attitudes of Robert Moses' time have died out, the infrastructure that was built remains. It's a lot harder to change the concrete and steel than it is to change people's minds. And what that means is that these engineering projects aren't just a matter of individual attitudes, they're also a matter of history. They're things that people have to deal with for generations. And this is what Langdon Winner is really thinking about when he thinks about artifacts having politics. He's not really a technological determinist, and he's not technologically neutral. He doesn't believe in technological neutrality. But he does think that artifacts have politics, and that the political situation, the political import of our technologies have a huge impact in how society develops. So I want to read this quote. I like this quote. This is from the Langdon Winner article. The article is much longer and very good if you want to check it out for your own posts. Winner says, "These things we call technologies are ways of building order into our world. Many technical devices and systems important in everyday life contain possibilities for many different ways of ordering human activity, consciously or not, deliberately or inadvertently. Societies choose structures for technologies that influence how people are going to work, communicate, travel, consume, and so forth over a very long time. In the processes by which these structuring decisions are made, different people are differently situated and possess unequal degrees of power as well as unequal levels of awareness. By far the greatest latitude of choice exists the very first time a particular instrument, system, or technique is introduced. Because choices tend to become strongly fixed in material equipment, economic investment, and social habit, the original flexibility vanishes for all practical purposes once the initial commitments are made. In that sense, technological innovations are similar to legislative acts or political foundings that establish a framework for public order that will endure over many generations. For that reason, the same careful attention one would give the rules, roles, and relationships of politics must also be given to things such as the building of highways, the construction of television networks, and the tailoring of seemingly insignificant features on new machines. The issues that divide or unite people in society are settled not only in the institutions and practices of politics proper, but also, and less obviously, in tangible arrangements of concrete and steel, wires and transistors, nuts and bolts." So, when Langdon Winner says artifacts have politics, he doesn't mean that every screwdriver should get a vote. What he means is that the way that we build, manufacture, and use screwdrivers has an impact on society, on our political arrangements, on the way that societies are ordered and develop. Screwdrivers, not just screwdrivers, but highway systems, vehicles, these things matter to the health and safety of individual people, to communities. It matters to the environment and to global warming, right? And all of these things are political issues. These are not just personal or individual issues. These are political issues. They're political issues in the sense that they require us to deal with each other. They have an impact on all of us. that that these are collaborative social arrangements, and that require our collective organization to manage. All right, so that's LinkedIn Winner, and that's really the end of the required readings. I do have a large section on optional readings, and the themes here are less directly about things like race and gender and gun rights and these sort of hot-button political issues. And these required these optional readings, I'd really like you to sort of step back and think in very abstract philosophical terms, if you're comfortable with that, about how complex organizations work and what are the ethics of dealing with complex organizations. Right? My idea here is that engineering projects are collective social projects. They require lots of people, lots of different perspectives, values, all sort of coming together for the thing to work. How do we manage that? How do we manage that in different contexts? Maybe the engineering projects developed at NASA are going to be different from ones that are developed by a private corporation, are going to be different again from sort of hobbyist or citizen science community putting together some engineering project. Right. So how do these contexts work? How do complex systems influence the ethics of these engineering projects? Okay, so these are very, very abstract questions, and I have a couple of resources for maybe helping you think about collective organization and how this changes the dynamics of things. The first video I have here, which I'm not going to show you any of, but is this Stephen Strogatz. Stephen Strogatz is a physicist, and he has this TED Talk from a while ago about how things in nature tend to sync up, and he's sort of interested in this idea of synchronization and how things synchronize. And he does a demonstration in the TED Talk video, which I will show you briefly in this metronome video. I'm going to turn this off really quick. So these are a bunch of metronomes, little timekeeping devices, and you'll see that they all start off at random times. So they're all sort of ticking along randomly, individually. Now there's no magic trick here, but what's going on is that these metronomes all sit on a table, and the table is free to jiggle a little bit. It wobbles. And so because the table wobbles and all of the metronomes are on the table, then the force of the metronome swinging side to side, some of that force is transferred to the table, and because all the metronomes share that table, that force is transferred a little bit to all the metronomes. So I'll let you watch the video if you're not convinced that this is actually happening, but if you watch it for a few minutes, you see that all of the metronomes start to tick in sync. You can also see the table wobbling back and forth a little bit. This one isn't synchronized yet, but if we go just a little bit further, you can see that it's starting to get in sync. And eventually all the metronomes will be perfectly synced up. There it goes. It's almost there. There it goes. So the metronomes are all synced. And they're synced here because, not because they were all designed from the top down to work exactly in step. I mean, you might imagine setting it up so all the metronomes work in sync by exactly starting them at the same time, maybe building some elaborate device to start everything at the same time. So that's one way of getting all the metronomes to sync. But another way of getting the metronomes to sync is by hooking them all up to a common infrastructure, and that infrastructure organizes and coordinates them in exactly the way that you see. So this is supposed to be a bit of a suggestive analogy, and I have a human case of this, sort of an exact example where the humans operate in the same way. So this is the Millennium Bridge. The Millennium Bridge was a bridge built in London, crossing the River Thames. You can see that there's no poles over the bridge holding it up. Instead, it has these stabilizing things on the side. These sort of poles on the side is supposed to stabilize the bridge and keep it from wobbling too much. Now, the bridge is over the river, and there's going to be wind blowing, and so the bridge doesn't crack or not too much stress. The bridge is designed to wobble left and right just a little bit, but on opening day, when there's thousands of people on this bridge, it ended up wobbling a whole lot. You can actually see how much the bridge is moving back and forth. You can see all the kids sort of stumbling around, and that. So what's going on here is that the bridge wobbles a little bit in the wind, and a lot of people on it also make it wobble a little bit. And because it's wobbling a little bit, all the people have to change how they're walking. So people usually walk with one foot in front of the other, but because the bridge is wobbling underneath them, they have to adopt this sort of side-to-side walk. I'll show you one more time here. You'll see the people are sort of doing a little penguin dance, where they're bobbing from left foot to right foot. And so the bridge is wobbling beneath them, and that's making the people, in order to maintain their balance, wobble from left to right. And because they're wobbling from left to right, it reinforces the side-to-side motion of the bridge. And this feedback loop ends up with the bridge swinging 6 or 7 inches side to side. Here you can see the kid sort of demonstrating the walking you have to do on the bridge. And because everyone's walking like this, you get this really dramatic movement in the bridge. Within a few hours of opening, the bridge ended up closing down because it was just too scary to walk on. It wasn't exactly unsafe. It wasn't like the bridge was going to collapse, but it was swinging side to side enough that people were tripping and falling. And it just wasn't a safe bridge. So now you see the old guy also demonstrating the side to side penguin walk. Okay, so it's possible to get a big crowd of people to walk in this penguin walk in a coordinated fashion. If you tell them all and practice for a couple of weeks, and like in a parade, you'll see dancers dancing in a coordinated way, marching along. It's possible to get a big group of people to march in a coordinated way, but that's not what's going on here. You didn't tell these people to walk like penguins down the bridge. People were sort of forced into this behavior because of how the bridge was designed. And again, this is the Millennium Bridge. This is the year 2000. This isn't a long time ago. It's not like our engineering techniques have radically changed in the time period since. These are modern, contemporary engineering techniques that just didn't anticipate the consequences of what happens when a bunch of people use this bridge. Right? What is the collective effects of a bunch of people sort of working together to make this bridge? So in this BBC documentary, they build a little sample bridge and explain why it didn't work and so on. If you're interested in the Millennium Bridge, it's an interesting documentary. And I have other examples here. Loren Carpenter's Pong experiment from the 90s. These are other examples of sort of large-scale systems where lots of people can work together. Twitch plays Pokemon, where lots of people can work together to accomplish something greater than any individual. And it's only possible because of the way that the technology coordinates the people. In the bridge case and in the metronome case, maybe that coordination is not positive. Maybe it strips people of their individuality to some extent. Maybe it represents a safety harm. But the Twitch plays Pokemon here, and maybe the Loren Carpenter example, Pong example. In this example, Loren Carpenter is one of the founders of Pixar. Worked at Apple for a long time. Was sort of interested in complexity and complex organization. And he, in the 90s, did this experiment where he got a bunch of people in a theater to play Pong. So a bunch of people, and the way it worked is that they all had these little light paddles, and on one side was red and on one side was green, and everyone had one of these paddles, and on the screen was a reflection of the audience, so you can see your paddle on the screen. But he also did some computer vision stuff where he was monitoring how much green and how much red was in the scene, and then he was using the amount of green versus red in order to control the paddles. So the left side of the room controlled the left paddle, and the right side of the room controlled the right paddle, and you were showing red or green in order to, like green made it go up and red made it go down, or vice versa, and you were showing red or green in order to make the paddle move up or down. So let me go and show you this. Yeah, so you can see this group of people acting collectively in order to drive this larger machine. And to some extent, there's a consensus process going on here, but it's not. They're not all agreeing and deciding and then implementing something, but they're sort of implementing directly without any big consensus process. If you watch the video, you'll see and hear people yelling at each other, red, 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 green, 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 but you don't have to listen to the people yelling. Some people are louder than others, and that big sort of chaos in that group ends up with this organized thing where they're actually two sides playing Pong. So thinking about the capacity of humans to sort of spontaneously organize these cooperative systems, how our technological infrastructure enables this coordination, how it influences it one way or the other. These are the kinds of things I'd like you to think about with some of these examples. Twitch plays Pokemon is maybe a good example some of you might be familiar with. A couple of years ago, Reddit did this thing, r/place, if you've never seen this video, if this video is unfamiliar to you, r/place is maybe the greatest art project the internet has ever done. I've been paying attention to the internet for a long time, and this is probably the best thing the internet has ever done. Over 1 million users added 1 million pixels to this image. For Reddit, for 3 days, you could add 1 pixel every 10 minutes, and then it was 1 pixel every hour towards the end of the thing. So users could go in here and draw 1 pixel at a time. If you gave 1 pixel every 10 minutes for the entire 3 days, you could do something like 700 pixels, which is about the size of maybe the flag right here. So no individual can be responsible for this entire image. Let me fast forward a little bit. You can see how this thing develops. You see that eventually they're drawing like the Mona Lisa, their Starry Night down at the bottom. You can see, the YouTube thing is in the way. You can see at the bottom there's also like the Windows 95 taskbar, the connection lost at the top. That's someone drew that. And remember, you're only doing 1 pixel at a time every 10 minutes. So this is a lot of effort. This is a lot of collaboration required in order to develop something like this. An interesting thing is that there are also trolls in this activity. You can see right here the void is sort of erasing people's things and turning everything black. So there are trolls. There are sort of image terrorists trying to destroy other people's work. But it doesn't totally work. The terrorists don't win. I mean, if I told you that the internet drew an image, you might expect a lot more sort of random chaos and porn and hate speech and so on. But that's really not what you see here. What you see here is a lot of creativity and collaboration and constructive activity. And it's surprising that it was able to work, to last, that the internet was able to come together and build something like this, despite the hostile vandalism of some users. So I have a video on r/place where I talk about it a little bit and talk about its relationship to politics generally and identity politics. I also have these neat little web apps. They take about a half an hour to go through. These are little interactive websites by Vihart and Nikki Case. Nikki Case is the one who's programming these. I think Vihart did the animations here. In this one, the interest is in how discrimination develops despite our intentions otherwise. So in these simulations, we have squares and triangles, and squares and triangles. So the thing about the simulation is that squares and triangles aren't entirely. So we're giving an analogy of racism, shapeism. But the thing is here that the squares and triangles aren't entirely shapist. They're not entirely racist. They do not want to be in a homogeneous community. So the rule that they follow at first here is that they'll move if less than a third of their neighbors are like me. So they want some diversity. They don't want it to be completely homogeneous. You see that if all of the oh, you can't see this because it's I need to go from here. Sorry. Here we go. So here's a browser. This is Parable of Polygons. In this website, you have squares and triangles, and they're partly shapist, but they're not entirely shapist. They want a diversity around them, so they will move if less than a third of their neighbors are like me. They're not happy in an entirely homogeneous community. They're not happy if they're entirely isolated in their community. They are happy, you see the little triangle here has a little smiley face, if their surrounding neighborhood, in this little square grid system, if their neighborhood is somewhat diverse, if a third of their neighbors, at least a third of their neighbors are like them. So they're, okay. So we'll see in this first demo, I'll just run through a little bit of this, that if I move all the shapes to where they're happy, and they get happy just based on that rule, so what I'm doing is I'm just, the ones that are sort of jiggling around are unhappy, and as I move things around, things become happy or unhappy. So I'm just moving things to see until I get to a point where everything's satisfied. If not entirely satisfied, then at least not unhappy. And you might notice something that's going on as I do this, which is that things are getting more discriminated, more segregated. as I go. Right? So when you start, things are sort of mixed, but people have this slight preference for a diverse crowd, and because of that slight preference, when you sort it all out, and I'll show you the sort of automated version of this. So here, there's a slight preference. The ones that are moving are unhappy, and if we get them to start moving, this just sort of randomly reassigns them until they're happy. You see that everyone gets happy when segregation's at 50%, over 50%. I can do that again. So the community is fairly diverse, fairly evenly distributed, but there's also some unhappy people because of this slight preference that all the shapes have, that at least a third of the people around them are like them. Again, remember, this is not totally racist shapes. They don't want complete homogeneous communities. They want a little bit of diversity. But because they have this slight preference, when you get them all acting together, the only way to satisfy everyone is to segregate the communities. Now, what the website allows you to do is change how racist they are. You can also eventually change not just the upper bound, but also the lower bound. I'll move if less than, I'll move if greater than, and you can see what impact these things have on the overall board. You'll see how difficult it is to overcome systemic discrimination and segregation, especially when people have even very slight preferences. The degree of segregation in some of these cases will be much more than any of the individuals in that system actually want. Just from this simulation. Given the simulation, the individuals want very low segregation, but the only thing that will make everyone happy at the same time is a system with much higher segregation than anyone wants individually. So this is an interesting phenomenon. There's implications here for some of the racial and ethics issues that we've talked about in class. Let me come back to the presentation. Not my cam. Okay. The other one here, the Evolution of Trust, is a similar website by Nikki Case that goes through some game theory simulations. It's also a lot of fun. If you're interested in some of these computer simulations of social cooperation, I strongly recommend these videos. You're free to write about any of these things in your posts. The last thing for this video, for this lecture, is this quote from Norbert Wiener. This is part of the required readings, but I'm leaving it to the end because this is a good closer. Norbert Wiener, in his autobiography titled I Am a Mathematician, he gives this statement, which I like quite a lot. And I'll just read it to close this out. Norbert Wiener says, Norbert Wiener, he was the one of the founders of cybernetics. He was a professor at MIT for a very long time. He was interested in control theory and organization, sort of at all scales. He's one of the important figures in cybernetics and complexity theory, complex system science. So he says, we are swimming upstream against a great torrent of disorganization, which tends to reduce everything to the heat death of equilibrium and sameness described in the second law of thermodynamics. What Maxwell, Boltzmann, and Gibbs meant by this heat death in physics has its counterpart in the ethics of Kierkegaard, who pointed out that we live in a chaotic moral universe. In this, our main obligation is to establish arbitrary enclaves of order and system. These enclaves will not remain there indefinitely by any momentum of their own after we have once established them. Like the Red Queen, we cannot stay where we are without running as fast as we can. We are not fighting for a definite victory in the indefinite future. It is the greatest possible victory to be, to continue to be, and to have been. No defeat can deprive us of the success of having existed for some moment of time in a universe that seems indifferent to us. This is no defeatism. It is rather a sense of tragedy in a world in which necessity is represented by the inevitable disappearance of differentiation. The declaration of our own nature and the attempt to build an enclave of organization in the face of nature's overwhelming tendency to disorder is an insolence against the gods and the iron necessity that they impose. Here lies tragedy, but here lies glory too. So what does Norbert Wiener mean by here lies tragedy, here lies glory too? Some of this is a little bit technical and maybe too abstract, but if you know a little bit of complexity theory and physics, if you know a little bit of the ethics of Kierkegaard, this quote is very, very juicy. So if you want to write about this, or really any of the other material in the lesson, feel free to have fun with it. Thank you very much for class, for listening to me talk for the last hour. I appreciate it. Good luck with your discussion forum posts, and I will see you next lesson.